The reason why Voyager had this golden record of human sounds and music was because this is one of the first several spacecraft launched with a trajectory that would never return to the solar system at all. And so if it never returns, there's a chance it could be discovered by some alien civilization.
Voyager 1 and Voyager 2, carrying 8-track tapes, relics from a disco-dominated era, journey into the cosmos. These iconic spacecraft have revolutionized our understanding of the solar system, providing intricate observations from billions of miles away. Voyager 1, as it pivoted back towards Earth, made a chilling revelation. Join us as we unravel the captivating discoveries made by this space probe at the farthest edges of our galaxy. Voyager's radical viewpoint through the heliosphere. In the late 1970s, NASA launched Voyager 1 and Voyager 2, marking a major event that piqued humanity's curiosity about outer space. These spacecraft embarked on a big mission to explore our solar system and beyond, promising to reveal the mysteries of space. Almost 5 decades later, these courageous explorers still send back lots of data, each transmission giving us valuable insights into space. Despite their old age, the Voyager probes stick to their mission, not bothered by their technology's limits. Though their memory is much less than today's smartphones, and their speed isn't as fast as modern internet, their lasting impact shows human ingenuity and persistence. These brave ships sail through space like old-time sailors, navigating the vastness of the cosmos. Since their launch, the Voyager probes have exceeded expectations, changing how we see the outer solar system. Their first job was to study Jupiter and Saturn, but they went further, giving us new insights into the moons, rings, and magnetic fields around these distant worlds. Voyager 2 made history by visiting Uranus and Neptune first, showing us things we'd never seen before. Despite being over 12 billion miles from Earth, the Voyager probes still work, thanks to NASA's smart engineering. By saving power and shutting down non-essential systems, they keep sending valuable data back to Earth. Their long life is proof of the careful planning and hard work that went into making them. The Voyager probes don't just teach us science, they also capture our imagination. Their pictures of Jupiter's storms, Saturn's rings, and the icy moons are everywhere, inspiring us to learn more about space. They've become symbols of human exploration, encouraging future generations to dream big. Now, Voyager 1 has found something strange in interstellar space, surprising scientists. But let's stay skeptical. What did it find, and is it really as amazing as some say? Let's dig deeper into this cosmic story. Let's go back to September 5th, 1977, when Voyager 1 started its journey from Cape Canaveral in Florida. 2 weeks later, on September 20th, 1977, Voyager 2 followed, joining its partner in space. Their first job was to explore Jupiter and Saturn and their moons.
Jupiter, which is, the king of the solar system, has this enormous capacity just to hoover in everything, right? Jupiter is a giant vacuum cleaner for space debris, which is really important for us because we might not be here if it wasn't for Jupiter acting kind of like the big brother of the solar system and clearing material out that normally might have pummeled the Earth and sterilized it.
But they went beyond, discovering new things in space. They began with exciting discoveries, capturing images of Jupiter's storms and Saturn's rings. Voyager 2 made history by visiting Uranus and Neptune first, showing us new things about these faraway planets. Every year, the Voyager probes went farther than ever before, breaking records for distance traveled. As they explored the outer solar system, the Voyager probes faced challenges like radiation and harsh conditions. But they kept going, sending back data that changed how we understand space. Their bravery and strength in the face of difficulties make them heroes of space exploration. Now, more than 40 years after they launched, the Voyager probes keep going, venturing into interstellar space. Their distance from Earth, over 12 billion miles, proves their determination. Even though they're far away, They still send valuable data that helps us learn about the universe. But let's not praise them too much. While the Voyager probes have done amazing things, let's remember to be careful. For example, they discovered that Jupiter and Saturn's moons aren't as lifeless as we thought. Voyager 2's trips to Uranus and Neptune were groundbreaking but challenging. Even with their amazing achievements, Voyager 2 is the only spacecraft to visit Uranus and Neptune. This shows how hard it is to explore space. As they keep going, NASA finds new ways to keep the Voyager probes working. By saving energy and turning off unnecessary systems, they make sure the probes keep sending data for years. But a big discovery has caused worry in the science world. People are excited to learn more from the Voyager missions. Every day, the Voyager probes explore new places, uncovering more mysteries of space. One interesting part of the Voyager missions is the golden record they carry. It's like a message to any aliens they might find.
We have ignition.
You see, 40 years ago, when NASA launched Voyager 1 and 2 into the solar system, each probe carried a gold-plated record.
The record has sounds and images that show Earth's diversity, proving how curious and smart humans are.
With greetings in 55 languages, music from various cultures, not to mention nature's symphony. On top of that, 115 images, a snapshot of Earth meant for any extraterrestrials who may stumble upon the spacecraft.
Even though they're old, the Voyager probes still do great work, helping us understand the universe better. Their story inspires future scientists and explorers. As the Voyager probes go farther, they remind us to keep exploring and learning. Their journey has fascinated people around the world, showing us how vast and beautiful space is. The data from Voyager 1 and Voyager 2 is like finding a treasure chest for scientists. It helps them learn more about space, from our solar system to the farthest reaches of interstellar space. The probe's instruments are so good, they take clear pictures and detailed data that scientists love. Even before they reached their main targets, they sent back pictures of Jupiter, giving us a sneak peek of what's out there. Voyager 1 and Voyager 2 tell us about the planets they meet, like Jupiter and Saturn and their moons. They also tell us about the magnetic fields and rings around these planets. Voyager 2 was the first to visit Uranus and Neptune, two planets way out there. This was a big deal and helped us learn more about these planets. Even though they're billions of miles from Earth, they keep sending back useful data, thanks to the smart people who built them. Voyager 1 and Voyager 2's instruments are perfect at their job. They take such clear pictures and data, it's like seeing everything up close. Everyone loves the pictures they send back, and it makes us want to know more about space. By showing us cool things about our solar system and beyond, they make us all want to learn more about space. Next, let's look at the explosive volcanic activity on Jupiter's moon Io that changed what we know about volcanoes in space. Voyager's close-up of volcanic Io. The excitement at the National Aeronautics and Space Administration's Jet Propulsion Laboratory was hard to contain when the first images of Jupiter's swirling clouds and its famous Great Red Spot were transmitted back to Earth. This excitement only grew when the Voyager probes began sending back images from Jupiter's moon Io, revealing startling volcanic activity that confirmed Io as the most volcanically active body within our solar system.
A whole planetary body covered in volcanoes that is zipping around Jupiter and is getting tugged by the other bodies. This is the Jovian moon Io, just Io, because its surface temperatures exceed 450 degrees Celsius, which is over 900 degrees Fahrenheit.
This small moon, slightly larger than our own, was not just another cratered ball of rock. It was a fountain of volcanic material, ejecting plumes so large they could easily envelop an entire country on Earth. As Voyager 1 neared Io, The instruments aboard started picking up odd signals suggesting massive geological upheavals, and the visuals stunned everyone. Enormous eruptions throwing vast amounts of material into space, painting a dramatic picture of Io's violent nature. The twin Voyager spacecraft, Voyager 1 and Voyager 2, were critical in these discoveries. Launched in the late 1970s, their mission was initially to explore the outer planets, but they provided a wealth of data that challenged our previous understandings of the solar system. Voyager 1's close flyby of Io, which brought it within 260,000 miles of the Moon, allowed it to capture these spectacular volcanic activities with unprecedented clarity. These eruptions weren't just a light show, they offered deep insights into the geologic processes at work. Io spewed molten sulfur high into space, which quickly froze and descended back to the surface like multicolored snow, covering the landscape. The vents themselves were much warmer than the surrounding terrain, with temperatures soaring above the average of negative 250 degrees Fahrenheit, typically found on Io's surface. This intense heat helped create lakes of molten rock and sent sulfur plumes towering into space, contributing to Io's brightness in infrared images. Moreover, Voyager 1's observations confirmed that Io hosted over 100 active volcanoes, more than any other known celestial body at the time. This intense volcanic activity was primarily driven by tidal heating. Io's interior was being constantly kneaded by the powerful gravitational pull from Jupiter and its other large moons, Europa, Ganymede, and Callisto, generating the internal heat needed to fuel the moon's volcanic eruptions. During their missions, the Voyager spacecraft took over 33,000 pictures of Jupiter and its many moons. These images not only showcased Io's fiery nature, but also revealed the varied landscapes of Europa, Ganymede, and Callisto, each moon telling its own unique story of cosmic phenomena.
Yeah, Europa's insane. I mean, into solar, and we didn't know this like a while back when I was a kid. Europa has an ocean. Europa actually has twice the amount of water that Earth does. So its ocean is larger. It's 100 miles deep, and it's covered by a 10-mile thick layer of ice. So who knows what is down there? There could be an entire aquatic ecosystem down there. So the discovery that we had these ocean moons, and there's others around the large planets as well, really was groundbreaking in terms of understanding whether there's other places for life in the solar system.
Among the unexpected discoveries was Jupiter's faint ring system, identified by Voyager 1. Though not as conspicuous as Saturn's, Jupiter's rings were a significant find, offering insights into the processes that might affect other celestial bodies within Jupiter's massive orbit. The exploration of these rings by Voyager 2 provided more detailed images and helped scientists understand their composition, mostly dust particles created from micrometeoroid impacts on Jupiter's smaller moons. The gravitational assist maneuvers that flung Voyager 1 and Voyager 2 toward the outer planets are examples of the mission's innovative navigation techniques that saved time and fuel. These maneuvers involved using the massive gravitational pull of planets like Jupiter to catapult the spacecraft to greater speeds and more distant trajectories. This efficient navigation was not just a triumph of planning and engineering. It symbolized the ambitious spirit of the Voyager missions, exploring further into the unknown than any other human-made objects before them. The ongoing journey of the Voyager probes serves as a testament to humanity's curiosity and desire to explore the cosmos. Despite the vast distance now separating these spacecraft from Earth, they continue to relay valuable data back through the deep space network. This network, consisting of facilities equipped with large antennas located in various parts of the world, including California, Spain, and Australia, is crucial for maintaining communication with distant space missions like Voyager. Each antenna, some as large as 230 feet in diameter, is a marvel of engineering precision, designed to track spacecraft billions of miles away. These giant dishes capture the weak signals sent by the Voyagers, amplifying them for scientists to study. Without this network, the data that has reshaped our understanding of the outer solar system would be lost in the vastness of space. The Voyager's findings have profound implications for science, particularly in understanding planetary atmospheres and the potential for life on other moons and planets. Voyager 1's encounter with Saturn's moon Titan and its rich, thick atmosphere provided valuable data that could be key in studying extraterrestrial atmospheres. The probe's journey through the heliosphere, the protective bubble that contains all the planets and shields them from interstellar radiation, has provided data critical to understanding our own place in the universe. The edge of this bubble, known as the heliopause, is where the solar wind meets the interstellar medium. Crossing this boundary, Voyager 1 sent back data that offered unprecedented insights into the nature of this interstellar space. As these spacecraft move toward and eventually pass other stars and continue their silent flight through the Milky Way, they carry with them not just scientific instruments, but also messages intended for any potential extraterrestrial finders, the Golden Records. These records contain sounds and images selected to portray the diversity of life and culture on Earth, from music by Bach and Chuck Berry to greetings in 55 languages and sounds of the natural world. These messages, crafted as a time capsule of earthly life, ensure that long after the Voyagers cease to function, they will still have something to say. This long goodbye, carried across the cosmic ocean, is humanity's way of reaching out into the universe, not with a whisper, but with a profound declaration of our existence. Let's see how the Voyager probes used old-school 8-track tapes to record their incredible space discoveries. Charting the cosmos with 8-track tapes. The Voyager probes are a profound testament to the engineering capabilities of the 1970s. These spacecraft embarked on their monumental journey into the cosmos equipped with technology that would seem rudimentary by today's standards, notably their 8-track tape systems. During a time when disco dominated the airwaves, these tapes were typically used for playing music. Now, in an era dominated by streaming and cloud storage, using 8-track tapes to record vital scientific data from billions of miles away might seem almost laughable. Yet, this choice highlights the ingenuity and foresight of the engineers at the time. Back in those days, digital storage was in its infancy and hadn't been tested in the harsh conditions of space. Engineers at the National Aeronautics and Space Administration, NASA, chose the more reliable 8-track tapes, known for their robustness and ability to store substantial amounts of data securely. These tapes were crucial for recording detailed observations of outer space, from the atmospheric compositions of Jupiter and Saturn to the intricate details of their moons. The ability of these tapes to withstand extreme conditions, intense radiation levels and severe temperature fluctuations from -250 degrees Fahrenheit to over 250 degrees Fahrenheit, was essential. Imagine these spacecraft, now over 4 decades old, continuing to send data back to Earth with technology that predates even the first personal computer. The 8-track tape system on the Voyager probes isn't just a relic of a bygone technological era. It's a cornerstone of the mission's enduring legacy. It's akin to finding an ancient television in your attic that not only still functions, but uses an old antenna to perfectly display modern digital broadcasts. The decision to use 8-track tapes over more contemporary digital systems was driven by a need for mechanical simplicity and absolute reliability. At the time, digital systems, while more compact and capable of storing greater amounts of data, were more prone to failures that could jeopardize the mission's critical objectives. The tapes provided a straightforward, reliable solution that engineers were confident would work effectively under the unpredictable conditions of space. As the Voyager probes ventured beyond the confines of our solar system, these 8-track tapes captured and preserved groundbreaking observations that have since revolutionized our understanding of the universe. Each tape had the capacity to store approximately 532 million bits of data, about 66 megabytes. While modest by today's standards at the time, this was enough to document significant discoveries, such as the active volcanism on Jupiter's moon Io and the complex ring systems of Saturn. These findings were not just astronomical triumphs, but also marvels of engineering. The data stored on the 8-track tapes provided the crucial information needed to make these scientific breakthroughs. Thus, the Voyager missions were as much about navigating and overcoming the technological limitations of the era as they were about exploring new frontiers of space. The resilience of these tapes underscores the robustness of the technology used during that time. It serves as a poignant reminder that sometimes older proven technologies can provide the reliability that newer, more sophisticated systems might not, especially in the challenging environment of space. The information stored on these tapes has enabled scientists to continue studying the outer planets and their moons, offering insights that no subsequent missions have matched. As Voyager 1 and Voyager 2 move into interstellar space, a feat scarcely imaginable when they were launched, their 8-track tapes still hold the primary records of humanity's first journey into this uncharted expanse. This reliance on seemingly outdated technology also emphasizes a crucial aspect of space exploration: the balance between using cutting-edge technology and depending on tried-and-true systems. This balance is vital in designing missions that are both innovative and practical, ensuring that they do not fail due to the untested nature of new technologies. The outstanding performance of the Voyager missions is largely due to the ingenious use of gravity assist maneuvers, or gravitational slingshots.
A gravity assist, the way people typically think about it is you send out a spacecraft and you want it to give it more speed than it currently has.
Right.
And so you find some planet that it sort of falls towards, and of course it'll speed up as it does that.
Right.
And we think of it as kind of a slingshot. You want it to sort of swing by, and it picks up speed in so doing, and it flings out the other side. And if you angle it right and position it right, you could head towards your next destination. And as a result, you can have multiple destinations in the same voyage.
Voyager 1 and Voyager 2, akin to interstellar marathon runners, needed a significant boost to reach the outer realms of our solar system. They found this boost not through raw power, but through a sophisticated dance with the planets, using their massive gravitational fields to catapult themselves across the solar system at speeds unattainable by conventional propulsion alone. As Voyager 1 approached Jupiter, the need for precision was paramount. The spacecraft had to arrive at just the right point in space at the right time to utilize Jupiter's gravity to accelerate toward Saturn. This maneuver required intricate calculations. A slight error could have sent Voyager 1 off course, spiraling into the outer solar system's cold, dark stretches. Engineers at NASA's Jet Propulsion Laboratory meticulously calculated the spacecraft's trajectory to ensure that Jupiter's immense gravitational pull would provide the necessary speed boost at the correct angle and velocity for its journey. The stakes were incredibly high. A minor miscalculation could have resulted in the loss of years of planning and millions of dollars, as well as the loss of a unique opportunity to explore the outer planets. Thankfully, these gravity assists were executed flawlessly.
So famously, Voyager 1 and 2, this is back in the 1970s when it was launched, they had trajectories were configured in such a way that it could get multiple planetary assists,
allowing both Voyager spacecraft to not just visit the planets, but to conduct a comprehensive tour of the solar system. Voyager 2, for instance, utilized boosts from Jupiter and Saturn to reach Uranus and Neptune, distant worlds that might have remained little more than faint dots of light for many more decades without this gravitational assist. The maneuvers required to achieve these assists were complex and required exacting precision. Voyager 1's journey involved approaching Jupiter at a specific angle and speed to enter the planet's gravitational well. which significantly increased the spacecraft's velocity. The spacecraft then had to exit Jupiter's gravitational influence at precisely the right angle to set its course for Saturn, traveling farther and faster than initially possible with its onboard propellant. Navigating this gravitational maneuver involved synchronizing Voyager 1's position and velocity with Jupiter's at the exact moment of closest approach. Continuous adjustments were likely necessary as Voyager 1 neared Jupiter, ensuring it hit the gravity assist target accurately. These adjustments were based on real-time data transmitted back to Earth and processed by NASA's Deep Space Network. This gravity assist maneuver was akin to a skilled surfer catching the perfect wave. Just as a surfer uses the wave's energy to accelerate and ride along its crest, Voyager 1 used Jupiter's vast gravitational field as a natural slingshot, propelling it through space at velocities unachievable with conventional space travel technologies of the time. The success of these gravity assists not only propelled the Voyager probes on their grand tour of the solar system, but also underscored the critical nature of precise, skillful engineering and astrodynamics. By perfectly catching the gravitational waves of the planets, Voyager 1 and Voyager 2 were able to visit the solar system's outer planets and provide humanity with its first close-up views of these distant, icy worlds. Discover how the Deep Space Network keeps the faraway Voyager probes connected to us here on Earth. The huge network that connects us to the stars. In their quest to master the concept of gravity assist, astronomers and scientists stumbled upon an aspect of the cosmos that, while less eye-catching than soaring spacecraft, is just as crucial: the Deep Space Network. As essential as the spine is to the human body, the Deep Space Network supports and facilitates the grand voyages of missions like the Voyager probes through what we call gravity assist maneuvers. Think of deep space not as a dazzling soloist, but rather as the orchestra's conductor, ensuring that the symphony of space exploration plays on smoothly and without interruption. This network, known as the Deep Space Network, might lack the sleek appeal of a spacecraft, but it is fundamental to our ventures into space. The Deep Space Network ensures that our spacecraft do not drift aimlessly through space, lost and unable to communicate their findings back to Earth. Encompassing a wide array of massive radio antennas stationed around the world, in locales such as California, Spain, and Australia, these antennas are the gargantuan ears of humanity, tuned to pick up even the faintest signals emitted from our mechanical explorers venturing through the void. The Deep Space Network's antennas, technological behemoths in their own right, are strategically placed around the globe in places like Goldstone, California, Madrid, Spain, and Canberra, Australia. These locations form a global web that allows constant communication with any spacecraft beyond our atmosphere, no matter Earth's position relative to the Sun. Each site is equipped with a 70-meter dish, about 230 feet across, crucial for tracking spacecraft over vast distances. Without these facilities, the likes of the Voyager probes could easily become silent wanderers, their discoveries never reaching the ears of those who eagerly await their data. The primary function of the Deep Space Network extends well beyond the mere reception of signals. It plays a pivotal role in both receiving and dispatching vital information across the incomprehensible void of space. When a probe like Voyager 1 sends back data from the edge of interstellar space, that signal is incredibly weakened by its interstellar journey. Nonetheless, these formidable dishes capture and boost these faint whispers from space, translating them into data that scientists can analyze. Imagine the precision required here. A signal travels billions of miles through space, weakened by distance and cosmic interference, only to arrive as a ghost of its original self. Yet, the Deep Space Network's sensitive instruments can not only capture this spectral signal, but also enhance it enough to provide usable data to scientists on the ground. The Deep Space Network doesn't just listen, it actively communicates, sending necessary commands and course corrections to spacecraft, ensuring that these distant Voyagers can fulfill their scientific missions. This network is in constant operation, maintained 24 hours a day by a dedicated cadre of engineers and technicians. This unceasing vigilance ensures that, no matter what time it is, the National Aeronautics and Space Administration can maintain dialogue with its spacecraft, a critical capability, especially during times of emergency or when precise maneuvers are required. The locations for the Deep Space Network's antennas aren't chosen at random. They are strategically positioned in places that offer optimal conditions for space communication. The expansive deserts around Goldstone, the secluded outskirts near Canberra, and the isolated plateau outside Madrid provide environments with minimal radio noise, crucial for the ultra-sensitive task of picking up faint signals from space. These antennas are marvels of engineering, designed to perform with unerring accuracy under the demanding conditions of space communication. They must track incredibly distant spacecraft with pinpoint precision, a task that requires an exacting degree of technical perfection to maintain the necessary alignment with fast-moving, distant objects. Thus, the Deep Space Network is far more than just an assembly of antennas. It is the critical infrastructure that binds humanity to its robotic emissaries in space. It allows for a continuous stream of information, which is vital not only for the operational success of space missions, but also for their survival in the unforgiving conditions of space. The insights gained through this network have profoundly expanded our understanding of our solar system and beyond, informing us about the atmospheres of planets, the structure of moons, and the dynamics of interstellar space. The network also stands as a testament to international collaboration in space exploration. Managed by the National Aeronautics and Space Administration, the Deep Space Network collaborates with other space agencies worldwide to support not only American, but also international spacecraft. This cooperative spirit is crucial in maximizing the returns of space missions, illustrating the global nature of our quest to explore the unknown. As vital as the cameras and sensors aboard the Voyager probes, the Deep Space Network acts as our link to these distant explorers. When Voyager 1 sends signals from the boundary of interstellar space, they arrive at Earth incredibly faint, having traveled billions of miles. Yet, thanks to the Deep Space Network's powerful dishes, these signals are not just received, but amplified, decoded, and made ready for analysis by scientists. The Deep Space Network does more than just receive, it also transmits. The ever-changing conditions of space missions necessitate frequent updates and commands, which are sent from Earth through the Deep Space Network. These commands ensure the probes can adapt to new scientific priorities or unexpected conditions as they arise. Operating continuously, the Deep Space Network ensures that the stories of the Voyager missions persist, facilitating a constant stream of communication that bridges the vast distances of space. This network does not merely function as a series of antennas. It operates as the very backbone of interplanetary communication, essential and always active. As we move beyond just talking about how we communicate in space and look towards the mysterious realms of interstellar space, we delve into a journey that's not just physical, but is also a profound testament to human ambition. Interstellar space, the vast region that lies beyond the protective bubble of our solar system, is surprisingly within easier reach than the distant edges of our solar system, like the Oort cloud. Imagine the solar system as a vast bubble, swelling under the pressure of the solar wind, a stream of charged particles the sun emits. This bubble, known as the heliosphere, acts as a shield that envelops the planets and protects them from the harsh galactic environment, filled with cosmic radiation and interstellar dust. At the edge of this protective bubble lies the heliopause, the boundary where the solar wind's influence ends and the interstellar medium begins. Initially, some thought this boundary was as close as the orbit of Jupiter. However, in 1993, more accurate measurements placed it at about 25 times the distance from the Earth to the Sun, or 25 astronomical units. Voyager 1 crossed this boundary roughly 20 years after these measurements, in 2012, marking humanity's first entry into interstellar space. This milestone was confirmed by a significant increase in plasma density detected by the spacecraft, a clear sign it had left the heliosphere. Despite the looming silence, the Voyager probes are on a path to explore near and beyond for millennia. Voyager 1 is set to pass within about 1.6 trillion miles of Proxima Centauri, our closest stellar neighbor, in about 16,700 years. Following its trajectory, Voyager 2 will also venture close to the same star, though it will arrive a bit sooner, in about 3,600 years. Long after their signals fade and their missions end, these probes will continue to orbit the Milky Way galaxy, long outliving the Sun and its protective heliosphere. Their journey is an everlasting testament to the tiny, pale blue dot we call Earth, a continuous exploration that knows no end. These spacecraft, though sturdy, bear a hint of delicacy. They might manage to send back one final message during their incredible journey. However, it won't be through traditional radio signals, and certainly not crafted by human hands. Aboard each Voyager is a unique time capsule, the Golden Records. These 12-inch, gold-plated copper discs, each sheathed in an aluminum cover for protection, carry the echoes of Earth's diversity. Engraved in the grooves of these records is a mixture of Earth's cultural heritage. 90 minutes of music from Johann Sebastian Bach's Brandenburg Concerto, Number 2 to Chuck Berry's Johnny B. Goode, images of human life, nature, and civilizations, and natural sounds like the chirping of crickets, the patter of rain, and a mother's kiss. Even Jimmy Carter, the President of the United States at the time of the Voyager's launch, left a heartfelt message on these records. It reads, "We cast this message into the cosmos." This is not just a greeting, but a hopeful note to the universe, expressing a wish that humanity might one day connect with other civilizations within the vast expanse. These records, with their golden sheen and hopeful messages, serve not only as ambassadors of Earth's rich tableau, but also as beacons of human achievement and aspiration. As the Voyager probes journey into the unknown, they leave us wondering, will extraterrestrial beings ever discover their messages? Like, comment, and subscribe to explore more cosmic mysteries with us.